Three rectangular blocks P, Q and R with respective weights W1, W2, W3 are stacked on top of each other on a table. If they are at rest, draw diagrams showing the forces acting on each block. So if we look for the forces on the first block, block P, so I'm going to draw the whole stack. So we will have the weight acting down from the centre of the block, acting downwards, which is W1, and then there will be a reaction, which we're going to call R1, between block P and Q. Now, the forces on block Q, so again drawing the same diagram, again we're going to have the weight W2 acting downwards, but we're going to have a reaction R2 acting upwards and a reaction acting downwards, which is opposite to this one here. So the same force but in the opposite direction. Now the forces acting on block R, we're going to have W3 acting downwards. We can have R3, the reaction between the block R and the surface it's on. And then R2, which is the reaction between these and this one, which is these two blocks and this particular block here, which you're going to call R2, which is equal and opposite to this one here. Now, if we, this one case here might be a little bit confusing. Why we're not considering the both the reactions of this block or the weight of these blocks? But if we look at it mathematically on how we set it up, so if we resolve for this situation, remember the blocks are at rest, so taking it upwards as positive, R1 minus W1 will be equal to 0. 0 because there's actually no movement, the block is at rest, and therefore R1 will be equal to W1. Right, now consider the second case, so we got R2 acting upwards, minus R1 acting downwards, minus W2 acting downwards, and that's equal to 0. And therefore, if we rearrange R1 to be W1, because we know that R1 is equal to W1, so R2 minus W1 minus W2 will be equal to 0, which will give that reaction 2 is W1 plus W2. Therefore, we can see here this reaction is actually the resultant of both these weights acting at this particular point. And going to the third case, we're going to have R3 acting upwards, and then downwards we're going to have to take away R2, take away W3. Now, if we, for R2, we put this, so we're going to take W1 and take W2, so it's equal to 0, because there's no movement. So R3 minus W1 minus W2. Remember, if you do minus and put brackets in, then that will become a minus. Minus W3 is equal to 0, and therefore R3 is the reaction having W1 plus W2 plus W3 acting on this point. Okay, so this has been a video to show you what happens when we have three rectangular blocks acting on a point, acting on a table, all stacked up against each other. I hope you've understood, and I thank you very much for watching.